A football coach designs a passing play in which a receiver runs down the field, makes a 90-degree turn, and runs to the corner of the end zone. A receiver starts at 40-40, turns at 20-10, and stops at 80-30. Did the receiver run the play as designed? First, let's list our points that we've been given in the problem. If we connect these points, we can form a triangle. The next step will be to use the distance formula to find the length of each side of the triangle. The receiver runs the play as designed if the path he leaves makes a right triangle, or in other words, a 90-degree turn. So we can find the length of each side of the triangle and then use the converse of the Pythagorean theorem to test whether he made a 90-degree turn or not. So to find the length between 40-40 and 20-10, we use the distance formula. Plugging into the formula, we have our distance is equal to the square root of 20 minus 40 squared plus 10 minus 40 squared, which simplifies to the square root of negative 20 squared plus negative 30 squared, which is equal to the square root of 1,300 feet. And repeating the same process for our other two sides, we find the distance between 80-30 and 20-10, and we see that that distance is the square root of 5,200 feet. And lastly, we find the distance between 80-30 and 40-40, and we see that the distance is the square root of 6,500 feet. Now we have the three sides of our triangle, and we can plug into the Pythagorean theorem to test whether this is a right triangle or not. Since the square root of 6,500 is the largest value, it must be the hypotenuse. Our two remaining values will be the other two sides. So plugging into the Pythagorean theorem, we have the square root of 1,300 squared plus the square root of 5,200 squared is equal to the square root of 6,500 squared. Simplifying, we have 1,300 plus 5,200 equals 6,500. So we see that 6,500 does equal 6,500, and this is a true statement. Therefore, the receiver must have made a 90-degree turn, and the receiver ran the play as designed.